Hello, everyone, and welcome to today's Tech Talk on indoor environmental quality for the commissioning provider. My name is Sherry Adams, and I'll be the moderator for today's session. Please note that throughout the Tech Talk, all the phone lines will be muted. This will minimize any background noise or feedback that could distract the presentation. When you first joined the Tech Talk, an attendee control panel appeared on the right side of your desktop. On the left side of this control panel is a small tab with an arrow icon at the top. Pressing this icon allows you to minimize and maximize the control panel. When maximized, you can use the control panel to submit questions. We'll be gathering your questions throughout the Tech Talk, and we'll leave a little time at the end for Q&A. If you're related to a particular slide, please include that number on the slide in your question. A PDF of these slides from this presentation will be sent out electronically to all those who are registered for today's Tech Talk. We will also be recording this and it will be available on our website under the resource section. There's a new password to access the Tech Talks, and it will be emailed to all of you after the presentation. Today's presenter is Jorge Torres Cotto. He is a mechanical and electrical engineer involved in the commissioning field since 2004. He gained hands-on experience by working as an HVAC technician and electrician prior to becoming an engineer. The coupling of his design and hands-on experience helped him understand building systems better from theory through operations and maintenance. He is also a current California board member of the BCA. So Jorge, I'm going to send this over to you.
Thank you, Sherry. Good morning to everybody, or good afternoon, depending on what geographic location you are currently at. So with the presentation, we'll try to explain a little bit how commissioning and indoor environmental quality are related. Some of you might already have figured this out. It took me, certain jobs and banging my head up against the wall against contractors or owners or operators to figure this out over the years. This is the agenda. I'm going to define the commissioning process fairly quickly. We'll get into defining IAQ and IEQ, and we'll also start discuss the different phases and what we need to be looking at as commissioning providers during each one of the phases of the commissioning process. These are more personal definitions than actual definitions from ASHRAE or different organizations. To me, commissioning is just the right thing to do. This is from experience, and usually when you start doing it, start getting involved in the commissioning process and it's done right, clients, owners, developers, contractors, and operators end up agreeing with you that commissioning is the right thing to do. For those of you that are involved with green projects or certifying under, like the LEED projects, the USGBC defines the commissioning intent as it's done to support the design, construction, and eventual operation of a project that meets the owner's project requirements, which is very similar to what ASHRAE tells us. And it's basically the process to meet the OPR, but they do emphasize the relationship between energy, water, indoor environmental quality, and durability. So this part that involves the indoor environmental quality, and we'll expand on this as we go through this presentation. And so due to the ASHRAE also in their standard 202, in their definitions defines that due to the integration and interdependency of facility systems, any performance deficiency in one system can result in less than optimal performance by other systems. And if we're going to be looking at performing commissioning duties or tasks on any project, and we're doing this to meet the owner's project requirements, we do want to look at it as a whole project, not system by system. Once we start focusing only on systems, we start losing track of how everything interacts, and the only thing this can end up being is detrimental to the project and to the owner eventually. Well, first of all, we'll define what indoor air quality is. And indoor air quality, or IAQ, as we like to play around with acronyms in this country, is basically the air quality within and around buildings and structures. So as you can see, it doesn't just talk about the air quality inside a building. It also talks about the air quality around the building, because we're basically bringing in the outside air, maybe treating it, maybe taking odors out, definitely taking out particulates if we are filtering it, whatever we have to do to it, and then bring it into our building and distribute it. And here, again, we're only talking about the air. And this definition comes from the US EPA, so the Environmental Protection Agency. And this can also work in what might be considered reverse. So if we have any air that we're also exhausting from our building, we also have to, sometimes get particulate matter filtered out, maybe control biological materials that could be noxious if we just throw them out, like in laboratories. We might have to treat it. We might have vapors or aerosols and things like that. So it's not all in one direction as to the air that's coming into the building. It might be air that's going out of our building into the environment, and can also affect people outside of our project scope. So for indoor air quality, we're looking at 4 parameters, which is basically thermal comfort, which would be, humidity, temperature. We're looking at contaminants, again, from the outdoors and from the indoors. So there might be contaminants that we want to avoid bringing into our building. There will also be contaminants that are generated inside our building, whether it's, printing services or a laboratory, or things that generate dust, debris, odors from a process or whatever we have inside our building. We might have contaminants that are new, like when we're bringing in outside air into our building, or recurring if we have a manufacturing process, if we have a hospital or a laboratory, things like that, that will just, on a constant basis, keep producing the same contaminants. We'll also be looking at odors if we're involved with IAQ. So we might want to control the odors on certain buildings, or if you have a restaurant, you might want certain odors to be present, because that might make the experience more palatable to the people that are in your restaurant. So it all depends on, if it's a good thing or a bad thing, if you want to emphasize it, or if you want to control it or eliminate it. So contaminants, you might have mold, moisture, and mites, and these can cause respiratory problems. It can cause allergies. If you have a cooling tower, we have Legionella, that is a big issue, or can become a big issue. You might have combustion products. So these can also cause respiratory problems, can cause cancer. You might have emissions that are generated indoors, and these can also cause a variety of problems. You might have pets, and these, if you're in a house, you might have a problem with pets. If you have a pet hospital, or even nowadays that, when I was younger, there were no pets allowed anywhere, basically. Now we have pets on planes, pets in restaurants, shopping centers, anywhere, almost anywhere where it's indoors. So these can cause problems. And if you want to avoid problems, you need to attack them and make solutions to avoid any possible problems. So for appropriate indoor air quality, you have to look at the physical, the mechanical, and the chemical properties to enable people to live and work in healthy and comfortable conditions. And so you have elements that are outside that you might want to keep outside. You have elements that are outside that you want to bring inside. Maybe to flush out the contaminants that are inside, if you have off-gassing, if you have VOCs, if you have printers that are producing dust and chemicals And so you need to flush these out, bringing in the outside air, but you also want to filter out the elements that you don't want from the outside. If you have a laboratory condition, the outside air definitely has to, you don't necessarily just take out particulates. If you have an embassy or a consulate where their concerns might be that they might get a chemical attack. So your filtration media will not only take care of dust, now you might have to consider filtration media for eliminating gases in case there's a chemical attack. And obviously there's cost considerations to that, there's operational considerations, there's equipment that now you have bigger pressure losses on these type of filters in comparison to, just your regular run-of-the-mill filters that you would use for an office building. So all of these need to be taken into consideration. Obviously, these would have been documented or anticipated when you were writing up the OPR, sitting down with the owner and asking them, so what are your needs? And those needs vary from project to project, depending on the utilization of the project or the location of the project, the process that is going to take place inside the project or whatever. So some of the factors to look at for indoor air quality are, you have physical factors. So you got temperature, you have humidity, you'll have mechanical factors. So now if you're moving air, you're moving it, what speed do you want to move it at? How often do you want to have an exchange rate? How often are you cleaning your indoor environment or flushing, your ventilation rates, pollutant, chemical factors. So what type of pollutants do you have? Do you just have solid pollutants, particulate matter, dust, things like that, or gases, like the example we gave on some facilities? So this is basically indoor air quality, different factors that go into it, the parameters that we have to look at if we're talking about indoor air quality. Now, if we're talking about indoor environmental quality, there's a slight difference. And indoor environmental quality is basically looking at, and this in comparison to indoor air quality, which is defined by the EPA, indoor environmental quality is defined by the CDC, so the Center for Disease Control. And these definitions are for the US, they don't necessarily apply worldwide, but worldwide there is a difference between indoor air quality and indoor environmental quality. And one of the basic things is that indoor air quality is a component of indoor environmental quality. And aside from just the quality of the air, we also have sound quality, the quality of the lighting, the odors, and then comfort. So these 5 different aspects or components are what encompass what indoor environmental quality are. So again, you look at indoor acoustic, lighting, odor, and comfort quality. And these are the parameters that define indoor environmental quality. So as commissioning providers, you can tell by some of these pictures, we get involved with lighting and daylighting controls. We're involved with the HVAC, so we deal with how the air moves and what the quality of the air is. If we're in an existing building, some of you may have already seen mold issues, maybe a problem with the envelope, maybe a problem with the ventilation, maybe a problem with different factors. So definitely doing commissioning and not looking at indoor environmental quality is doing a disservice to the owner, whether we like it or not. So the indoor environmental quality has a international organization, and the mission of the IEQ-GA is to provide basically an acceptable indoor environmental quality. So that takes into consideration thermal, indoor air, lighting, and acoustic qualities to occupants in buildings and places of work around the world to make sure that knowledge from research and IEQ gets to be implemented in practice. So it's taking this theory, the idea is to get this theory and actually put it in practice all the way from design or from concept to operations of any facility or project, building, hospital, whatever that use may be. So if we're talking about indoor environmental quality, one of the aspects is to look at indoor air quality. So for indoor air quality, if we're concentrating on that 1/5 or that 20% of indoor environmental quality, we need to look at the HVAC, which as commissioning providers, most of us look at the HVAC. So this would be looking at temperature, humidity, contaminants, because we usually, if we're moving air, we have, filtration media to control contaminants, whether they be solid materials or gases, depending on the use. We're looking at the enclosure, because the enclosure basically is what separates our indoor from the outdoor. So one of the purposes of the enclosure or the envelope is to keep air and contaminants separated from the indoor to the outdoor. And it's not necessarily, and again, I emphasize, it's not necessarily to keep contaminants out, it's to keep them separated, because your indoor may be more contaminated than your outdoor, depending on the use of your facility. But the purpose is to keep the outdoor from the indoor separated. Then you might have chemicals from all your furnishings and your finishes, carpets, paints, adhesives, and again, they might be very noxious. They might not be, depending if it's, you run a mill office and they took some care into providing paints and sealants that have low VOCs or less contaminants, less off-gassing. But there's certain applications where you can't, provide paints and sealants and things like that that are not as noxious, because they have to contain chemicals, they have to resist corrosion, they have to resist acids and things like that, which may make them, just as bad as whatever is going to be dropped on them. So you might have a production facility or an industrial place or a laboratory that has some paints that are pretty noxious, but they're required. So, and you have to take this into consideration for the occupants of the building. And again, this has to be defined so we can anticipate that and make any means necessary with the different systems and elements that we'll be utilizing on the project, or that the owner intends to use on the project. Thermal conditions. The systems you're basically looking to control or define the thermal quality would be the HVAC and the enclosure or the envelope. These are the two major systems that would either hinder or help your thermal quality either be good or bad. Under visual quality, obviously your lighting systems, whether you have a day lighting system. And so if you're looking at your day lighting, then that's your enclosure or your envelope is also involved in the quality of the day lighting and what controls you have, what geometry you have, what finishes you have. And an example that you can see there, it's basically the same space, but by providing higher partitions on in an open office, cubicle type space, you will get much different lighting quality. The corridor at the end or away from the windows is much darker, which eventually would also make you probably use more energy, because now you're going to have to light that corridor more than you would with lower partitions. So these aspects, the lighting, the enclosures, the geometry, and the finishes, if you use light colors versus darker colors. And these are things that affect, how much energy you use and how the feeling or the quality is for the occupant of the space. For acoustic quality, again, HVAC will have an impact, depending on what systems you utilize for your HVAC. If you have VAV systems compared to fan coils, or just, or medium-sized air handlers, all these things how you distribute the air. All these things will have an effect on the acoustic quality. Lighting, if you use certain type of light fixtures, you will have different noises generated from light fixtures with electronic ballast compared to electromechanical ballast, which you don't have many new ones now, but you might have an existing facility. And if you're analyzing those acoustical properties in an existing facility and it has older light fixtures, that has to be taken into effect. The enclosure, it depends on how it's built, how much mass you have. If you're close to highways, if you use single pane glass, dual pane glass, or laminated glass, all these things will affect how noise either gets into your building or how noise reverberates in your building, depending on what materials are chosen for the finishes, what the geometry, or what the shape of your building is. And good example, usually auditoriums are not your run-of-the-mill, just it's not just a cube. There's a purpose behind the materials that are chosen. They might not just be drywall. You might have wood or something that absorbs sound better. You'll have, if you've ever been in a theater, you'll notice that there's a plethora of different shapes and sizes of materials that they look aesthetically pleasing, but they're also there for a reason, to absorb sound so it doesn't bounce and create the wrong effect, or the effect that's not desired. And here's a little list of the difference between some of the active elements and the passive elements that will help, or your indoor environmental quality, or they also might hinder it, depending on what's chosen and what's defined by the owner, what he wants, or what he or she thinks he wants, and also responses to the OPR by the design team. We might get incorrect responses sometime, and we've probably all seen that. So some of the passive elements are the envelopes. You have the roof, the walls, the floors. For ventilation, if we're using natural ventilation, that is considered a passive element. For lighting, as far as active elements, you also have, and you can notice it looks very similar. The envelope is both an active and a passive element. We do have the ability to open and close the envelope if we have operable windows. And if it's automatic, it says it's active. Our lighting is both passive and it's also active, again, because we can turn our interior lighting on and off. And we might have buildings that don't have any shading devices, or shading devices might be fixed, or shading devices might be automated, or they might be operated manually. So shading devices can either be passive or they can be active. The ventilation system is definitely an active system if we're talking about mechanical ventilation. So all these things, as you can see, they all interact, and one thing will affect the other. Whatever decisions we make on the envelope will affect our ventilation, our comfort, our lighting, and whatever decisions got affected and on the lighting system might also affect our lighting system. And so under commissioning due diligence and trade on, we have to be able to do our best job for the client. So the indoors refers usually, or not usually, it refers to what's in the building. So what is really in the building, or what is the building? And like I said before, a building is basically an environmental separator. Its only purpose is to separate the indoors from the outdoors. So basically, this long list of items is what the enclosure or the envelope is trying to do. It's trying to control all these different things. So depending on how we build our wall will affect how each one of these items are controlled, whether good or bad. But if we don't think about how the enclosure is built, where it has openings, what materials we choose for it, how we control those openings, we won't be able to attack all these things. And these are questions that are always good to ask the owner when they're making a decision, or ask the architect or the designer. Are you taking into consideration all these items, or what's really important to you? Because maybe, and again, it all depends on what the purpose of the building is, but maybe keeping insects and rodents out might not be a big consideration, but because you might have a hotel next to the beach where you want the experience to be you getting bitten by insects and you're letting the air and the wind through. But if you have a laboratory, whether it's biological or chemical laboratory, controlling things from the outside might be a big consideration. Keeping that in consideration, what we just mentioned, an isolated system, in an isolated system, a process can occur only if it increases the total entropy of the system. So there is literally what this means is there is no such thing as a free thermodynamic lunch. These are facts. Heat goes from warm to cold. Moisture goes from more to less, and air goes from higher to lower pressure, and gravity acts. Everything, if we go back to what science tells us, can help us make decisions in a much more informed way than what we think is common sense. Because common sense sometimes leads us down the wrong path. Common sense is usually the least common of all the senses, and it doesn't always make sense. If you notice the model or the mock-up that was set up for this experiment, you can notice the wind direction is going from right to left, and the smoke is actually being driven from in the opposite direction for the building adjacent to it. So this is similar to what a wing does to lift a plane, where you have the wind blowing in one direction and you will have a negative pressure side and a positive pressure side. So the taller building is generating on the downward side a large negative pressure section, which is causing plumes from the shorter building to be thrown at the taller building, even though the wind tells us that it should have been going the other way. So sometimes our common sense assumptions don't match what reality is. And we really need to pay attention to this, because sometimes common sense, again, does not match science or reality. And sometimes it's hard to explain that to an owner or a designer or an operator, that this is how things are going to work, even though, our common sense tells us that it will work exactly in the opposite direction. So now moving into the different phases of the commissioning process, if we're in pre-design phase, and how this affects the indoor environmental quality, or what things we need to be considering at each one of the phases. So the most important part, and this is at the pre-design or conceptual phase, is documenting the owner's project requirements. So we need to extract information from the owner so he can tell us exactly what he wants, or as best as possible for his project. So we can decide what's important to him, and we can also find out, how the engineer, the architect is supposed to attack these problems to come up with solutions that will meet what the owner wants. So, and if you look at ASHRAE, one of the things, and it's up there on the top 5 that needs to be defined, is indoor environmental requirements. So this includes temperature, humidity, and ventilation, aside from all the other elements that we talked about that define indoor environmental quality. So, acoustic requirements might not be important on certain projects. They might be very important on other projects. Lighting might not be important on certain projects. And again, it all depends on what the owner wants, and that's why we need to sit down and document as early as possible exactly what the owner wants, or the operator, to find out how this is going to get resolved during the design phase. During design, then we have to review what's being designed, the basis of design, what's written, what the narrative says. Does it meet what the owner really wanted in the beginning? If it was written down on the OPR, we have the drawings, the specifications. Do they reflect what the owner wants, or are they starting to deviate? And if they're starting to deviate, we need to ask the question: why are they deviating? Why are we not following the owner's project requirements when we're making up drawings and specifications? And is the owner aware of this? And is the owner willing to live with this? And if the owner's in agreement with it and he's willing to live with this, okay, then we have to look at, okay, what are the ramifications of this? Whether it's for the envelope, the air conditioning, the lighting system, all the systems that are related to the indoor environmental quality. And again, some of these, we might look at it if we, it's really not our job as a commissioning provider, but I think from what we've seen up until now, the lighting is part of what we're doing, so that affects the visual quality. The air conditioning affects what we're doing, or is part of our scope of work, and that affects, that can affect humidity, and that can affect what the temperatures at a wall are. That can affect where the dew point is inside a wall and where it will possibly condense. So if we're looking at the air conditioning and where the building's located, and we're not looking at the envelope and what problems might occur inside a cavity of a wall of our building or the owner's building, we're really doing a disservice. And again, these are not really complicated analysis. You can use really sophisticated tools, or you can use simple analysis, at least to find out if we're going to have the possibility of a big or small problem. And then we can assign more resources to it if we really find that there might be an issue. If we find that definitely there won't be an issue, then, problem solved, we can move forward. But we have to do our due diligence if we are, assigned to performing commissioning tasks, and look at the interaction of the different systems. So again, these are some of the analysis that might be done at an envelope. And again, I'm putting an envelope as an example because the envelope will be related to our lighting, it will be related to our HVAC systems, and it will be related to how we can keep contaminants separated from the indoor to the outdoor.
Jorge, it doesn't sound like we could hear you right now.
And then during construction, we also need to look at, how things are being built, whether it's the HVAC, if the ductwork being installed as it should be, is it being cleaned? Can you hear me now?
Yes, we can hear you now. You've been going in and out a little bit, but we can hear you now.
Yeah, I got right before you told me, I got the little bubble telling me that it lost connection for a while there. All right, so during the construction phase, we'll review submittals for any of the systems that we believe are interrelated. And again, it all depends on the scope of work and what your contract is. And we'll also verify, or what also has to be verified is the installation. So whether it's an envelope, whether it's the HVAC system, whether it's the lighting, it's the controls for the lighting, or any other system that we've been hired to perform services on, we need to look at if it's being installed correctly. Because, you know, if it doesn't get installed correctly, it definitely will not work correctly. Now, one of the things that, you know, we might not currently be getting paid to do as commissioning providers, but these are things that definitely will impact the indoor environmental quality, are materials that are being used as paints, sealants, furniture, flooring, anything that ends up being inside a building will affect the indoor environmental quality, or can affect it. And usually these are systems that we don't even look at twice. We might, if we're doing a really good job on our lighting and lighting control system commissioning, look at the color of the paint. But we might not even be looking at the chemistry of the paint and how that might affect the building, you know, if we have to do a flush out, because the paint that we're using will off-gas to a big extent, or if we're using adhesives for flooring, or if the flooring doesn't have adhesives, and how will that affect our indoor environmental quality? If we're keeping dust, or we're generating dust after, you know, or before, or sequenced correctly, depending on different phases of the construction process. If we're generating dust and we're moving air, did we anticipate, you know, extra filtration media or not? So these are different elements that we need to take into consideration during the construction process. So to avoid contamination in other in other systems, or between systems, or inter-systems, and also to, again, if it was defined by the owner during the writing of the OPR, then these are definitely things that we need to bring up to the owner and ask him, do you want me, you said this was important to you when we wrote the OPR. Now, currently this might not be in the budget, it may not be in our scope of work, but do you want, if it's important to you because you wrote it down in the OPR, do you want somebody to be tracking these items? Do you want somebody to be looking at, you know, the interrelationships that exist between your furniture or your finishes and your air conditioning and your lighting and your envelope and all these other systems that are interrelated? Or do you just want us to look at things in silos? But again, if we don't ask these questions to the owner when we're getting hired, you know, the questions won't get answered, and then, you know, these things won't be looked at the different phases of commissioning, and they probably won't be tested at the end, and we might have problems at the end. And having problems at the end of a project or during a project will only give us unhappy clients, and that's probably the last thing we all want, especially if we're providing a service and we're getting paid for it, and we want to get paid for it in the future by getting repeat clients. So at the end, or near the end, when we have the acceptance phase, and we'll be doing testing, if we're hired to do it, or if we make it clear to the owner that it's in his best interest to test for indoor environmental quality, or, you know, and it doesn't all have to be on burdened by the commission provider. You might have different specialists depending on what systems you're looking at. But communication between different providers for doing the testing, or for the different systems and inspecting the different systems, is key. As we all know, for commissioning, communication is key. And then once you turn over the building or the project, you know, it's making sure that all this information gets transferred to the O&M staff. And one of the important things is the OPR ends up being converted into the owner's operating requirements or procedures, and how things were tested, what the relationships are. Make sure this is well understood by the O&M personnel, instead of them instead of them having the traditional mentality of every system is a silo and all I have to do is change filters on the HVAC system, and without looking at what the interrelationships are between the different systems. And this I think would be a very positive change in the way we deal with commissioning. Traditionally, we only look at it in silos where we're specialized in one thing. We're specialized in looking at the HVAC if we're mechanical, or looking at the lighting if we're electrical, or controls inclined. If we start looking at what the actual relationships are between the different systems, I think we can provide much better services to our clients and to the industry as a whole. I've got a few examples of things that I've seen in a variety of projects, and the pictures here are all during construction. Bottom left, there's some adhesives and sealants and chemicals that were used on the job that apparently were not even approved in the submittal process. So this would affect what the owner really wanted, and it's just not following rules. There's puddles on the window frames. There's already a bunch of black mold, and this job is barely in construction, so it hasn't even been completely sealed up. And all they're trying to do is paint over the mold to hide it, literally. Which we all know, if you just paint over mold, it'll just come back out in a few weeks or so. These are problems with existing buildings. If you look at it on the left, this is how we found literally every single room in a hotel. These are exhaust fans in a tropical environment. So if you're not dragging air through a hotel room in a tropical environment, you are going to get big humidity problems and big mold problems. So literally every single room had the exhaust ductwork disconnected, which caused, if the bottom picture, you can see there's drippings. Since you can't control humidity, you're not moving air. Literally everything is sweating inside the rooms and in the hallways of the rooms. And you add to that you're putting carpets. So if you have something that's just dripping all over the place over carpet, which is an absorptive material, you're only asking for trouble. So decisions like putting a carpet in a humid place without being able to control the environment are probably not your best decisions out there. Skylights that need to be covered up with a tarp was probably something that somebody didn't think about, or the selection of the glass. Is it just single pane glass? Does it have any low E or reflective qualities? Obviously it didn't, and that's why they had to put a tarp over a skylight, a huge skylight. Not changing, they're in operations. If you don't change or you choose the wrong filter, it will end up being plugged, like the lower picture. The other consideration is what do you have in your surroundings? If you have a refinery in your neighborhood and you want to control the indoor environment in your building that's next to that refinery, you probably have to have some pretty good filtration media, or take into consideration how you're going to wash the air before it gets into your building. If the indoor air quality is important to whatever process you have or whatever use you have in your building. And so if we go a little step further, so any decisions that are made by the architectural and engineering community definitely have an impact, or can have an impact, whether positive or negative, on the human health and well-being of the occupants of that space. And this can be extrapolated into the bigger urban environments. So decisions that are made by urban designers, whether building a residencies near an industrial plant is fuming or deciding not to have residence or chemical plant refineries. Those are decisions that are made by urban designers, authorities, and that can have a big impact, on health for the long term. Obviously, maybe some of you, there's also things that you might consider. And, thank you for your time, and if you have, and your attention, if you have any questions, feel free to ask them, and if anybody's out there, then probably, Sherry, you might have the questions if anybody wrote them down.
Thanks, Jorge. It doesn't look like we have any at this moment. We are just about out of time, but if somebody does have a question while I'm just making a quick announcement, please feel free to ask one right now. Just as a reminder to mark your calendars for this year's annual conference, September 25th, 26th, and 27th in Schaumburg, Illinois. Check out our website for some exciting things that we'll be doing this year, and also keep an eye out for some email announcements that will be coming your way very soon. Let's see, Jorge, I don't think we have any questions, but if anybody does, since we have run out of time and you have any questions, you could send them to me and I'd be sure to get them sent on to Jorge. We were having a little audio issue, so if there were some things you missed that you had some questions about, please let us know and we'll try to get those questions over to him as well. But we really appreciate, Jorge, your time and expertise today. And on behalf of all of BCA, I'd like to thank everyone for your participation in today's Tech Talk, and have a great day.
Thanks, Sherry, and thanks for anybody that attended or will attend.
Thank you, Jorge. Bye-bye.
Bye.